All right, good evening, everyone. Welcome to today's class. We're going to be solving a couple of questions today. And as usual, we're going to be solving more of past questions. So applying all the previous knowledge you have already to several questions. All right, the very first question we'll be solving today is on mathematical induction. And we'll be solving a question that came out last year. So we're given this particular question last year. Five n plus 2 open bracket 4 raised to power n plus 1 minus 1. So the question said we should prove by using mathematical induction that this particular function is an integer multiple of 4. Is an integer multiple of 4. So this is based on last year's question, and I want you to pay real attention because this question actually carried a total of 6 marks. So you're expected to prove this using mathematical induction. Looking at what we have here, I'm sure you understand the processes and the steps we use for mathematical induction. The very first thing we do is to have our n being 1. We use that to test run the hypothesis. So we are told now to prove that this function is an integer multiple of 4. So let's test for the base case, and the base case will be when our n is equals to 1. So when n equals to 1 is our base case. So let's try and check if when we fix in n equals to 1 here, are we going to get an integer multiple of 4 as our answer? So if this n equals to 1 works, we can go on to test for n equals to 2. And then later on, don't forget what we did in our previous class. We will then assume that n equals to k was true before we then go on to the final step where we're going to prove that n equals to k plus 1 is true. So let's start with our base case for n equals to 1. I want everyone to pay real attention so that we can get the best from this class. So when we fix in n equals to 1 into this particular function, we'll be having 5 into bracket 1 plus 2, 4 raised to power 1 plus 1 minus 1. This is 5 plus 2. This is 4 raised to power 2 minus 1. This is 5 plus 2 times 16 minus 1. This is 5 plus 32 minus 1. This is 5 plus 31. This is 36. All right. Now, let's try and investigate, is 36 an integer multiple of 4? Of course, yes. We can also write 36 as 4 times 9. So obviously this tells us that 36 is an integer multiple of 4. So for the base case, for n equals to 1, we have been able to prove that this is true. Now you can go on to try for n equals to 2. Let's try and test for n equals to 2 and let's see what our resultant will be for them. It's not compulsory you test for n equals to 2, but just for the sake of those that will probably need to really understand what integer multiple means, let's go on to test for n equals to 2. So when n was equals to 2, obviously our n will no longer be 1. So we'll be having 2 in this spot. And of course, we will no longer be having just 5 times 2 now will be 10. And we'll be having 4 raised to the power of 3. And 4 raised to the power of 3 will be what? That will be 64. 4 raised to the power of 3 is 64. And 64 times 2 will give us 128. 128. Of course, we will no longer be having 5 here, we'll be having 10. So this is, we're trying to investigate for n equals to 2. So what we have here is 127. Okay. Oh, sorry. The question was actually 5 raised to the power of n. I'm seeing that now, not 5n. It's 5 raised to the power of n. Sorry for that. It is 5 raised to the power of n. I'm holding a past question right here. It is not 5n. So obviously it worked for 5 raised to the power of 1 was still 5. But for this particular situation, we'll be having 25, not 10. So this will be 5 raised to the power of 2. So instead of 10, we'll be having 25. So we'll be having 25, 25, 25, 25. So our final answer will be 25 plus 127, and that will be 152. All right. For those that may not have understood integer multiple of 4, 152, let's try and find out, is it an integer multiple of 4? Okay. What does multiple mean? That means, on your 4 times table, will you get to a place where you will say 4 times something and it's to give you 152? Of course, yes. If you go on with your multiples of 4, when you get to 4 times 38, you are going to get 152. So that means this 152 is an integer multiple of 4. So we have been able to prove that for n equals to 1 and n equals to 2, we have this particular function to be true. All right. The next thing to go on to do now, so I believe you are all getting what we're doing. We then need to go on to assume that n equals to k was true. Don't forget, we have done this before. When you are proving the base case and you are sure that it works, then you go on to now assume. So this is what we call the inductive hypothesis. This is the phase we call the inductive hypothesis. So we will assume that n equals to k is true. So this is not something you need to sweat on. Once you have been able to prove that the base case is true, just go on to assume that n equals to k is true. All right, if n equals to k is true, this is the places where I need you to really pay attention for you to get the best there. If n equals to k is true, that means 5 raised to the power k plus 2 into bracket 4k plus 1 minus 1 is true. Now, but pay attention. We are assuming that n equals to k is true. So we are saying this particular function, of course, replacing n with k is true. What does that mean arithmetically? What that means is that the result of this, if it is actually true, will be 4 times a particular integer. You saw that for our base case, when our n was equals to 1, we were able to get 36, and then we said 36 was equals to 4 times 9. That means it was true, and then it was a multiple of 4. That was 4 times 9. Now, when we did for n equals to 2, we got 152, and we said that was 4 times 138. Sorry, 4 times 38. So that was 4 times a particular integer value. So in this particular case now, if we're going to say that n equals to k is true, that means this particular function must give me 4 times a particular m, a particular integer. This m is an integer value. It's an element of an integer value. So all we're saying here is that if this particular hypothesis is true, then the answer must be 4 times any integer. That m could be anything. That m could be 100, it could be anything. But this is just the basis. I'm sure you can understand what we're saying here. Now, this is what we call the inductive hypothesis. This is where you just assume n is true. The next step, which is now a very important step, the final step, is for you to go on to now prove that n equals to k plus 1 is true. So we call this the inductive step. And in this step, we want to prove that when n was equals to k plus 1, it's going to be true. So this is the real work, and I want you to be very much focused. So we go on to do what we can all do, and that's fixing wherever we saw our n, we fix in k plus 1. So we go on to have 5k plus 1. Wherever we saw n, we are fixing k plus 1, plus 2, 4. In this case now, n is k plus 1. So we have k plus 1. We put that in bracket because that was n, then plus 1. Then minus 1. So this is what we will call, we want to prove now. This is the inductive step, and we want to prove now that this is true. So let's try and open this up. Of course, we can solve this a little bit further, and let's see what we can do here. Of course, this will turn to plus 2. That's 5 raised to the power k plus 1 plus 2. This is a JUPEB past question for last year. So you could be seeing something like this in your exam this year. So this us summing 1 plus 1. Now we can try to reshape this form, the same form, but we will just be we will try and one thing we want to do here, let me try and give you a heads up. We want to make, we want to bring out 5k, 5 raised to the power k here, so that we'll be able to isolate from our inductive hypothesis. That means when we assumed n was equals to k, we want to bring out this 5k. So we'll fix this 5k into what we are dealing with here. So this is what we are proving. Don't forget, this is n equals to k plus 1, which we want to prove. So, but what I want to do next is I want to make it something like this. Of course, from your law of indices, this is same thing as 5 raised to the power 1 times 5 raised to the power k. I'm sure nobody has an issue with that. Plus, now there's something I want to do here also. I'm trying to, because I want to use my inductive hypothesis here. So I want to try and bring this particular, don't forget, this what we're dealing with here, this is for when we're dealing with k plus 1. But because as always, you tend to use your inductive hypothesis, that means when n was k, we use it to make solutions for our k plus 1. So I want to change the form of this in order to accommodate this inductive hypothesis. So in this case now, I'll be writing 2, but I'll be bringing out, I'm sure you agree with me that this is the same thing as 4 times 2 multiplied by 4 times k. I'm sure you agree that I can write 4 raised to the power 4k plus 2 as this. And then also, I'm sure you also agree that I could write it as 4 times 4, because 4 raised to the power 2 is the same thing as 4 times 4. So the reason why I'm doing this is that I want to, you see this 4k plus 1, I want this place to look like that. So I want to bring out one of the 4 to multiply 2, but I want to leave 4 raised to the power k plus 1 inside, so that I will be able to get a semblance with what we have here. Because we will be making use of the inductive hypothesis very soon. So this particular place now, what we have here, I will be having, rather than having just 2 outside, I'll bring in one of the 4 outside. That's this dot here represent times. So I'll bring in one of the 4, and I'll be having 4k plus 1 left. Don't forget it was 4k plus 2. That k plus 2 is like 4 raised to the power 2. That was 4 times 4. So I brought out one of the 4. I'm left with just one of the 4, which made it k plus 1. So this is what I will be doing, so that I will be able to make use of my inductive hypothesis. 2 times 4 obviously is 8. So I can change this place to, instead of writing 2 times 4, I can change this to 8. So this is where we are at. Don't forget, we are trying to prove that n equals to k plus 1 is true. All right, so hang on there. We want to do something next. I want to make from our inductive step now, because it's our inductive hypothesis that I'll be using to make my proof, as always. So from my inductive hypothesis, look at it. We said if n equals to k is true, that means this particular function, when you fix in n as k, must be equals to 4 times a particular integer number, which we termed m. Now, if that's the case, this means I am not going to be wrong if I decided to rewrite my 5 raised to the power k to equals 4m minus 2 4k plus 1. Then in this place plus 1, because I'm shifting everything here to this other side. I'm isolating, making 5 raised to the power k the subject of formula. So the reason why I'm doing that is because I want to use this particular 5 raised to the power k. I want to use it here. So that's what I want to do. So I want to use it here so that I will then be able to, since you told me this was true, we assumed that n equals to k is true. So me fixing this here won't be wrong. So I will use that now to go and prove if this particular n equals to k plus 1 will also be true. So that's the whole procedure we want to follow. All right, now that we have this, I want to go on to fix 5 raised to the power k into this my inductive step when kn was equals to k plus 1. This is last year's question, so this is very, very likely to be seen. So please pay real attention and try everything possible to understand what we're doing. Don't forget, the m we wrote here is any integer, is an integer value. Please don't forget, it's an integer value. So it will be anything, 69, 68, 70, whatever. So now what we have to do next is we'll fix 5 raised to the power k into, let's call this equation star. So fix it into equation star. So what we're going to have now is we'll be having 5 raised to the power 1, which is still 5, into bracket. Now we're fixing our 5 raised to the power k there. 4m minus 2 into bracket 4k plus 1 plus 1. This is me fixing. I'll fix the whole of 5k there. And don't forget, I have this plus 8 into bracket 4k plus 1 minus 1. So here we are. I have fixed in 5 raised to power k into my equation for n equals to k plus 1. So don't forget what we are trying to do. Just keep in mind the question. The question is for us to prove that this particular function is an integer multiple of 4. And we already defined an integer multiple of 4 to be that answer where we can say 4 times something. So 4 times 1, 4 times 2, 4 times 9, 4 times 6, 4 times 38, whatever 4, well, as long as we can say 4 times something, then that's proven. So that's what we want to prove here. So look carefully at what we have now. You can see that if we decide to open this bracket, the bracket of what we have here, this will be 20m. We're opening this bracket now. This will be 20m minus 10 into 4k plus 1, then plus 5, then plus 8 into bracket 4k plus 1 minus 1. So I'm sure you can see something. And if you can't see, let me try and open your eyes to see it. Look at what we have here. Imagine you defined 4 raised to power k plus 1 as x, for instance. You know that it's more like you're having minus 10x plus 8x. So I won't be wrong if I decided to make my solutions as 20m, then minus, so I can have 20m, then minus 10 plus 8, that will be minus 2, 4k plus 1. I'm not wrong to do that. Then 5 minus 1, that will be 4. All right. So this is where we have gotten to. Let me try and clean this up so that you don't get it confused. We are trying to prove that that particular function is an integer multiple of 4. So these are the procedure. Don't forget, we started by proving for the base case for when n was equals to 1, we got our answer to be 36. And we said that was 4 times 9. Then we went on to prove for when n was 2, we got our answer to be 152. That was 4 times 38. So we went on to assume that our n equals to k is actually going to be true. And we said if that was true, that means we're going to be getting 4 times a particular integer. So we define that integer, which we are not going to put any value to it, to be n. So from there, we then went on to make our inductive step, which was when n was equals to k plus 1. So we'll fix that into our function, and this is what we are solving. So we made use of our inductive hypothesis. That was when n was equals to k. We used it to assist us to make the proof. That was why it was from it we brought out 5 raised to power k. So now we're here, and what do we have to do now? Don't forget, we are heading towards a position where we are trying to prove that this particular n equals to k plus 1 is going to give us an answer of 4 times something. You need to always know where you are moving towards. So what we're looking for is that if we're able to prove that this thing we have now is equals to 4 times something, whatever it is, as long as it's an integer, as long as we have 4 times an integer value, whatever was inside here, doesn't matter, then we are going to be able to conclude that our by using mathematical induction, we've been able to prove that that function is an integer multiple of 4. So that's the whole idea. So let's see now, we have gotten to this particular stage now. Let's try and isolate 4 out. Let's try and factorize 4 out. So if we factorize 4 out here, we have 4 into bracket, we're left with 5m. Then if you factorize, I'm sure you know that you can factorize 4 out here because this is 4 raised to power 1. This, if you break this out using the law of indices, it will be 4 raised to power k times 4 raised to power 1. So if I bring out 1 4 out, I'll be left with minus 2 4 raised to power k. I'm sure you should be able to understand what I just did there. So I had 4 raised to power k times 4 raised to power 1. I brought out one of the 4 out here. This is it here. So I'm still left with 2. Then I'm left with just 4 raised to power k. And in this case, I'm left with plus 1 because this 4 goes out. All right, now we're getting very closer to our conclusion. Now let's pay attention and let me quickly address how I'm going to make my conclusion very easily. I've gotten my conclusion already because you see, we told you that m was an integer. So just put any integer in your mind. I'm sure you know what integers are. Put any integer in your mind. Of course, you can use an integer, obviously, but it will be better if you use like a positive integer. But now go on to use a positive integer for m. Maybe you put 2, maybe you put anything, maybe you put even 60. Now, don't forget, k also was an integer because when we used k to represent our inductive hypothesis where we said k, n was equals to k was true. So k is an integer value. I'm sure you know that if m and k are integers, if you fix in those integers into this particular what you have here, this is not something anybody cannot understand. Fixing any integer into this place, any integer you want, you will notice that the result you will get will always be an integer. Just put any integer there. Put m as maybe 60, maybe put k as I don't know, maybe 8. Just put in something there, and then you'll be able to discover that the final answer here, when you are done doing it, you will not get something that is not an integer. You will get an integer value. So what does this tell me? This tells me that I can decide to represent, for instance, let me represent this my answer here as p. So that means I can say everything I do here, whatever the answer, I can call it p. So p also will be an integer. That means if, what I will say now is that I will say if m and k are integers, then p will also be an integer also. And if that is the case, then that means my solution for n equals to k plus 1 will obviously be equals to 4 times a p being an integer. So that means if this is the case, that means I've been able to prove that n equals to k plus 1 will also give me an integer multiple of 4. So simple. So that's the final answer. So once you are able to prove this, that your answer is giving you 4 times a particular integer value, which in this case, p was the integer value we used. You can use any value you want to use. You can use x, you can use y, but we're using p. So, and once you're able to prove that n equals to k plus 1 arrived at 4 times a particular p value, which was an integer, then we are good to go. So we have been able to prove by mathematical induction that the function 5 raised to power n plus 2 into bracket 4 raised to power n plus 1 minus 1 is an integer multiple of 4. If you're able to do this, this is 6 marks. 6 marks last year's Math 01. This is question number 1, and actually the very first question for last year. So I'm sure you guys were able to follow. I know some people will be finding it quite funny because once you don't yet understand the whole concept of mathematical induction, then this question will be quite an issue. Can I get feedback from you guys? Let me just get some feedbacks. I want us to solve a partial fraction quickly. We have a question on partial fraction. Last year's past question also. Can I get feedback quickly? We still want to solve a couple of questions. We have questions to solve. Who is there? 5. I did not fix in 5 anyway. Where did I fix in? Okay, 5 raised to power k. Okay. Okay, where I fixed in 5 raised to power k. Okay, and obviously that was from my inductive hypothesis. Okay. Okay, people are following. Okay. All right. Okay. When we get the video out, don't worry. I didn't get m was just obviously m was just an integer value. I just fixed there that whatever it could, you could use y. It doesn't have to be m. This P is just fixing, you could have called your own Y. You could have called it Z. You could have called it anything. Like, what I just know is that whatever, if you put in M an integer value here and put in K an integer value here, you will get an integer value. And I decided to call that integer value P. You could call it Y, or you could call it Y, but I just know that if you fix in M as an integer value and K as an integer value, you will still get an integer value. So I called it P. So that's 4 times an integer. 4 times an integer. So I called it P. Okay, somebody's talking about sequence and series. I think we have many questions to solve. So I think maybe if you have, you could see me personally or contact me personally, but I really want us to move to other questions. And sometimes we may not be able to get perfect communication to everybody because you are all on different understanding of the whole topic generally. So, but once you have understood the whole steps, this thing is quite very, very easy. So you have the base case test for when n was 1, when n was 2, if you want to, and then go on to assume that n was equals to k was true. So we did that, and then you go on to prove that n equals to k plus 1 is actually true. So, and you mostly used to use your n equals to k to help when you are solving for n equals to k plus 1. All right, so let's go to another question quickly. For those of you that are interested in solving ahead, let me read the question out quickly and then I'll write it. You're told to resolve 10x squared minus 8x minus 7 divided by x minus 1 in a bracket, then in another bracket, x squared minus 7x plus 5. So you are told to resolve that into a partial fraction, obviously. So let me write that again. What we have is, we have 10x squared minus 8x minus 7 over x minus 1, x squared minus 7x plus 5. So we are told to resolve this into the form. This is the form we are told to resolve this into. A over x minus 1 plus bx plus c over x squared minus 7x plus 5, where a, b, and c are real constants. Where a, b, and c are real constants. So this is question number 2 of last year's question. And the whole question carries 4 marks under partial fraction. I'm told to resolve this into this form. This question is quite very easy and simple. How many of you can solve this quickly? Anybody there, you have a great idea of how to solve this? All right, let's solve this very quickly because of time. You don't need to sweat over this. Once you have a question like this, I'm sure you know what to do. What to do is quite very simple. What you want to diffuse the denominator of this whole thing. Like, this is an equation now. This equals to this. So you are told to find a, b, and c. So what you're going to do is just quite simple. All of the denominator, you want to cancel them out so that you can just have a straight linear equation, or not even linear here, it's actually going to be quadratic. So you don't want to have all these denominators. So what do we do if we are going to eliminate these denominators? So what we have to do to eliminate them completely is that we will be multiplying by the LCM of both of them. The LCM of these two is actually the multiplication of 2 of them. You don't need to sweat over that also. When you multiply these two together, we give you the LCM. So anyway, we're going to be multiplying this whole equation. We're going to be multiplying by x minus 1 then x squared minus 7x plus 5. So we're going to multiply this equation by that function. So, of course, when we multiply this equation by this function, this whole denominator will go. So we don't have to waste time rewriting that. This whole denominator goes away. So we'll be left with just 10x squared minus 8x minus 7. So if we multiply this with this will cancel the denominator. So let's see what happens for this other side. If we multiply this particular function with this value, of course, this x squared, this x minus 1 will cancel the x minus 1 here. So you'll be left with a into bracket, just this one left. That will be x squared minus 7x plus 5. I'm sure you guys can follow what I'm doing here. So let's see for this one. If I multiply this whole thing with this equation with x minus 1, sorry, not an equation, with this function, x minus 1 and x squared minus 7x plus 5. Of course, this particular one will cancel this one. Then you'll be left with x minus 1. So obviously, we'll be having plus bx plus c into bracket x minus 1. Pardon, the board is quite small. We have to write that c better. Okay, let me just write it much better. So we will have bx plus c into bracket x minus 1. So this is the very first step. The very first step we have to do. And what are we seeing here? Yes, we're in a very beautiful place now. And what we have to do next is, let's ignore this left-hand side for now. Let's try and work on this right-hand side. So I'm going to work on the right-hand side here. So I'm ignoring the left-hand side. I just want to open these brackets up. Let's open the brackets up and see what we're going to get from there. So the whole idea is that, let me quickly give you a heads up. The whole idea is that you want to, after opening this whole bracket, you want to bring together all the values that has x squared. And then you will equate it with this particular one that has x squared. Then all the ones that has x, you equate it with this one. Then the ones that don't have anything at all, they don't have x, they don't have x squared, you equate it with this one. That's the whole idea. It's quite very simple, and something I believe everyone can excel in. So let's try and see what we do here. So we open this bracket, we have ax squared minus 7ax plus 5a, then plus, of course, opening down, we have bx squared. You can see an x squared is coming out there again. Then bx times minus 1, we have minus bx. Then c times x, we have cx. Then c times minus 1, we have minus c. So that makes sense. Now, I can see x squared here. I can see x squared here. So what I want to do next is to bring together all these guys that have x squared. So let me bring these guys together. I'm sure you can flow with me. So I'm bringing, look at what I'm bringing here. I'm bringing these two together now because I can see they are the two that has x squared. So I don't need to waste time. I can just decide to do a plus b. Then I bring everything into x squared because obviously I know, of course, I'm factorizing x squared out. So this is what comes out from there. I'm sure you guys can follow. There's no big deal in it at all. So let's try and see the other one where we have just x alone. We don't have x squared. So we can see minus 7ax here. I can see minus bx. I can see cx. So what I want to do is to just bring everything into one place. So let me write plus. Then I bring all of them into one place. I can have minus 7a. I'm sure you understand what's going on here. Minus 7a. I want to factorize x out. Minus b. Minus b is all that is left here. Then plus c. Then everything, I'll put the x outside here. I'm sure you can flow with what's going on. We have minus 7a. We have minus b. we have C. Those are the values that have X. So what do we do next? I'm left with just two values that don't have X at all, and that will be 5A minus C. I'm sure you can see that. Good. Yeah, so this makes sense. I'm sure you're flowing with what we're doing. Now, as I said already, the whole hang towards all these things we're doing, all the things we're trying to do here is that we want to equate the ones that has X squared. Now look at, this is X squared here. This is X squared here. This is X here. This is X here. This one doesn't have anything. So this one will move with this. So let's bring them together quickly. So obviously, if you said this whole thing was equals to this whole thing, because that's the idea here. You said this thing is equals to, don't forget the use of equation. This thing was equals to this thing. If that was true, which must be the case, if this is equals to this, that means A plus B must be equals to 10, because you said this was equals to this. So A plus B must be equals to 10. That's the way we are doing this. So I'm not wrong if I write A plus B is equals to 10, because you told me that this was equals to this. It's just very understandable. So look at this other one. If you told me this was equals to this, that means everything here must be equals to minus 8, because you told me they are equals to each other. Someone is saying B plus C. Something, am I missing something there? I don't know. I saw something. I hope you're not confusing yourself. Okay, so if you told me that this thing is equals to this whole thing, don't forget this whole thing we opened up here was just the resultant of this thing. So obviously, I'm not wrong if I say that minus 7A minus B plus C is equals to minus 8. I'm not wrong at all. Because if you told me that this is equals to this, then that means this particular one must be also equals to minus 8. And in continuation also, if they were all equal, which is true, then that means 5A minus C, which is the constant value. Those ones don't have X at all. 5A minus C, they don't have X at all, must be equals to minus 7. So it's just basic. So these are the three things we have been able to bring out from the whole solutions we have been working with. Now let's see what happens now. You don't need to sweat this again. You just need to work carefully. So let's try, and because we can see all these things now, how do we go on to find out? Don't forget, we are interested in finding A, B, and C. So how do we find A, B, and C? Number one, what is, from here I can say that my B, I'm not wrong if I said my B was equals to 10 minus A. I'm not wrong. I believe you all agree with me. So, and I'm not also wrong if I said that my C here was equals to 5A plus 7. Now, if you can see what I'm trying to do, just for those of you that you probably are wondering what's going on here. If you can see what I'm trying to do now, I'm trying to make B an expression that has A, and also make C an expression that has A, so that when I go and fix in B and C into this my second equation, everything will now have A. Look at it. This is the equation I want to use. I can see B here, I can see C here. I can see that A and C was together here, A and B was together here. So I go on to make B subject to formula. B was 10 minus A. I go on to make C subject to formula. C was 5A plus 7. So if I put B as 10 minus A and C as 5A plus 7 into this particular equation, everything I will have just A. And then from there, I'll be able to find my A. I'm sure you guys that are following, you can find the answer very quickly before I even do my own. So go on and solve in case you know what you are doing. And if not, you can wait. I'm going to still do the solution also. So for those of you that are having issues in probably understanding some of these things, I will still do a complete video on all these topics, because we may not, I told you these classes will be majorly for questions. So if you don't have the perfect If you don't have the perfect understanding, how is 5a not having minus? How is 5a? 5a is not going to have minus now. Where is 5? Where is 5a going to have minus from? I don't know what you're talking about, but 5a doesn't have minus. I think we have been doing a good job. I think so. So again, I will do full understand full explanation of this topic, and you'll be getting those content very soon, so that we are able to you are able to flow. Because if you don't have true understanding of these things prior to these classes, it may cause a little ish, but don't worry, you're going to really understand it. Don't worry. And then when this video comes out, when I release it, you can go through it step by step again. I guess you will understand it far better at that point in time. So looking at what we have here, we have putting all this into my equation. I have minus 7. I have minus 7a. Now, instead of writing b, I'll be writing 10 minus a. Instead of writing c now, I'll be writing 5a plus 7. And then they said it was equals to minus 8. So that's the way we're doing this. So from here, I can see this is minus 7a minus 10 plus a plus 5a plus 7 equals to minus 8. Looking at this, we can see this is minus 7a, this is plus 6a. That's minus 7a plus 6a. Minus 10 plus 7, that will be minus 3. Okay? So, and we'll be having minus 8. So this will be minus a equals to minus 8 plus 3. So minus a here will be equals to minus 5. Our a here is equals to what? 5. For those of you that got a as 5, you are perfectly correct. Can you see how simple this is? And this is last year as well. Once you are able to do all this, your marks are sure. So now, if I got my a to be minus 5, to be 5 rather, so I don't need to waste time. How do I get my b and c? Don't forget, we already said b was equals to what? 10 minus a. If my a is 5, that means my b will be 10 minus 5. And that will be what? 5. So my a is 5, my b is 5. b equals to 5. It should remember for c, let's try and find for c. You put in your 5 here plus 7. What do you get there? That's 25 plus 7. That's what? 32. That's 32. So our a is 5, our b is 5, our c equals to 32. This is 4 marks. This is, although this was 2, so I'll tell you where you're going to catch the remaining 2 marks. This was actually 2 marks. And then the other 2 marks, they now said, so don't forget, you were told to resolve this into this form. So what you have to do here is to go on to fix this, to fix everything back into this particular form. So you're supposed to make this, you're supposed to have the final form. Don't always forget to write it as we were told. So you're going to have, the form is going to be 5 over x minus 1 plus 5x plus 32 over x squared minus 7x plus 5. So please always try to put it in the form that you were told to put it in. This is the final answer. So that's how we solve these things. Quite very simple. So look at the other question that was asked. This one was also 2 marks. You were told that using a, b, and c, solve the equation. Now you can take the equation down. The equation given was 2bx minus a equals to c plus 3. 2bx, look at it right here. 2bx minus a equals to c plus 3. So you were told to solve the equation. So who can give that answer in some few seconds? You're told to solve the equation 2bx minus a equals to c plus 3. right, without wasting time, our b is 5, so that will be 2 into bracket 5x minus our a is 5. 5 equals to 32 plus 3. This will be 10x minus 5 equals to 35. This is 10x equals to 30. Our x equals to 3. Somebody said x equals to 4. Is x equals to 4 or 3? Oh, actually, it's actually equals to 4. Sorry, I saw it. I saw the mistake. Thank you very much. Thank you. Thank you. Bravo. That's nice. So you fix this here, not plus. It's not minus. It's 40. So x equals to 4. That's nice. That's nice. That's nice. That's really nice. Okay, so that was an oversight. So that's 2 marks. You are done with all this and you are ready. You're ready. This was last year's question. So so for you to get the whole 15 marks, by the way, just so you know, the question I asked we solved yesterday, that was a question on matrix, is actually the first 7 marks, and then plus this 4 marks, that's 11 marks. So you're left with 4 marks. So I'll be giving you the question that will earn you the last 4 marks now, and I expect you to be able to solve it. So I'm sure you guys are flowing with this class, and I'm sure you're enjoying it. This is the road to excellent success, which is what we all desire. So you guys should just keep on keeping on. You don't have to. Those of you that you're having some issues in understanding all these things, don't worry. In time, everything will get better. So look at the question you were told to solve that will give you your full 15 marks. You were told to solve for sec x equals to 5 minus tan square x. So you said the question read, solve for x in the interval 0 degree less than or equals to x less than or equals to 360 degree. So this was the question for the last 4 marks. If you're able to solve this, I'm telling you, that's 15 over 15 in your Maths 001 if you were able to solve all this. So by the way, before we end this class, I want you to try and solve this. We'll solve this question before we end this class. Then, how was you didn't tell me the result you got yesterday, because don't forget, we solved for the adjoint and we solved for the inverse. But the last question, which was 2 marks, you were told to find the solutions to the system of the linear equation. So can you guys tell me what you got yesterday for x1, x2, and x3? How many of you were able to solve the question, the matrix question yesterday? Okay, x1, someone said x1 was equals to 2. Okay, what was x2? And anybody confirm that was what you got also? x2 was 1. Okay. Okay, 2 minus 1 and 1. Well, somebody got x2 to be 1. What's going on? X3 was 1. 2, 1, and minus 1. Okay. X1 was 2. X2 was minus 1. X3 was 12 over 7. Are you sure? 2 minus 1 and 1. Looks like many guys are getting 2 minus 1 and 1. Please, you have to be very perfect and accurate in these things. All right, what's the solution for sec x equals to 5 minus? This is a question you need to pay attention to. There is something that you really need to pay attention. This is not as you need to understand how to solve for the reciprocal of trigonometric functions. That's the sec theta. So let's try and solve this question. So we have this very interesting question right in front of us. We're told to solve this and we're going to get our 4 marks. All right, let's see. What do we do? Of course, I need to recollect that from my identity, I know that sec square theta is equals to 1 plus tan square theta. Or in this case, let me use sec square x so that you can understand better. Is equals to 1 plus tan square x. All right. So if this is the case, what do we do here? Don't forget, this is not sec square x, this is sec x. So it makes more sense to change tan square x to make everything look to have sec x. Don't forget, the whole idea of all these things is to try to bring everything to just one trigonometric function. So which one are we going to bring it to? In this case, it's far much feasible to bring everything to having sec. So what do we do? I have sec x, 5 minus, now my tan square x now will be equals to sec square x minus 1. Sec square x minus 1. So you can see that from here, I can make tan square x the subject of formula, and this is what I will be getting. So from here, I can see that sec x will be equals to 5 minus sec square x plus 1. So this will be sec x equals to 5 plus 1 will be 6. That will be 6 minus sec square x. Are you following, or is it making sense? All right, so what do we do next? We can fix everything on one side. We have sec square x plus sec x minus 6 is equals to 0. So we're looking for, we can decide to make x as, maybe we'll use y now. Let y be equals to sec x. So what we can have here is this will be y squared plus y minus 6 equals to 0. So this is a quadratic equation already. So what is that value that would, if we decide to factorize, what are we going to get? We're going to get, that will be minus 3. That will be 3 minus 2. So we'll be having y squared plus 3y minus 2y minus 6 is equals to 0. I'm sure you guys can follow and you're flowing with what we're doing here. Don't forget, my y was sec x. This is the road to getting 15 over 15 in your whole one. So it's quite very possible. I'm sure you can see this. That's a whole question. We have exhausted the whole question, and it's quite very simple. And you guys you are able to understand it. So what we have here is y into brackets y plus 3 minus 2 into bracket y plus 3 equals 0. So we have y minus 2, and we have y plus 3 equals 0. So that means our y is equals to 2, or our y is equals to minus 3. But I'm sure you have not forgotten what my y was. My y was sec x. My y was sec x. So I'm okay with writing it now as sec x is equals to 2, or sec x is equals to minus 3. This is nice, right? I'm sure these things are very easy. I'm sure many of you can flow with what we're doing, because these are things we have done. It's quite very easy and very understandable. So now this is the place where a lot of you, of course, we have to apply our understanding of angle of any magnitude now. So how do we apply this? We want to say x is equals to arc sec 2. That's what we're going to do. I told you already, when you are solving angle of any magnitude, what you have to do is to first ignore the sign. So for this other side, you will say x is equals to arc sec. In this case, you ignore the sign 3. All right. So now you don't have sec on calculator. You don't have sec on your calculator. So what do you do here? I told you that when you have a situation like this, what you do is, instead of using sec, you'll be using the reciprocal of sec, which is cosine. So cosine is what you use there. So you'll be using arc cos. In this case, I'm using 1 over 2 rather than using 2. So that's what you use there. In this other case, you'll be using the same thing. You'll be using arc cos, because don't forget sec x is equals to 1 over cos x. So in this case, you'll be having 1 over 3. So that's the whole idea towards all these things. Quite very easy and understandable. So can you punch that on your calculator and let's get an answer? What do you get when you fix in? What is arc cos 0.5? The arc cos of 0.5 should give you, is it 60 degree? Okay, so you have 60 degree. So x here is equals to 60 degree. Okay, and for this other side, what's 0. That's 0.33, 1 over 3. So what is arc cos? Arc cos of 0.333, you'll be having 70.53. That's nice. All right. So what do we do next? In this case, we have to investigate using our quadrants. And we have, I'm sure you remember the quadrant. Our quadrant, let me use here. All students takes calculus or hard sugar to coffee, whichever one you want to see it as. In this case, I'm deciding to go the other way around, anti-clockwise. Okay, so we're dealing with cos. Don't forget, whatever you deal with in cos, this is for cosine. So cosine is positive in both first and fourth quadrant. So you'll be saying if cosine is positive in first quadrant and fourth quadrant, sec is also the same. So sec is also positive in fourth quadrant. So in this case now, your value as sec x was equal to a positive 2. So that means you are interested in the first and fourth quadrant because sec is positive in first quadrant and fourth quadrant. So my quadrant of interest is quadrant 1 and quadrant 4 for this particular situation. So how do I find for quadrant 1? I told you already, when you're dealing with quadrant 1, what you have to do is to just replicate your x. So x here is equals to 60 degree. That's so simple. And for the quadrant 4, the rule that goes on there is 360 minus x. Don't forget, I'm sure many of you are used to theta, but in this case we are dealing with x. So you follow using whatever the angle you are given. We're not using theta here, we're using x. So now with 360 minus 60, the theta here, the x here is 60. That will be 300 degree. All right, so the two values we are interested in here is this and this. All right, let's see for this other side. We were able to get okay, now for this other side, we're interested in you see our sec here is negative. We said our sec was negative, so we have to use our quadrant. Don't forget your quadrant is the final decision maker. Whatever you got here doesn't mean it has to be part of your answer. Add sugar to coffee. Okay, adding sugar to coffee. What does it say about sec? Of course, sec is positive in first and fourth, so it's negative in second and third. So our quadrant of interest is second quadrant and third quadrant. Second quadrant and third quadrant. So what is the rule that goes on for our second quadrant? And the rule that goes on is 180 minus x. In this case now, we're having our x as 70 points. So we're having 180 minus 70.53. What does that give you? 180 minus that It gives 109.47. All right. And for the third quadrant, our rule there for the third quadrant is theta plus 180. Here we have 70.5.53 plus 180. So let me write that. Let me write the final answer here. That will be what? What's 70.53 plus 180? We have 250.53. Okay, that's nice. 250. Let me write that here. 250.53. So this is our value of interest. 109.47 and 250.53. So at the end of solving this particular question, we can conclude that our x values is 60 degree, 300 degree, 109.47 degree, 250.53 degree. Please, I want to say this one is not part of it. Please do not include this answer there. Your quadrant is the final determination of your final answer. Oh, somebody said the board is rough. Of course, we have to write things on it. So if you were here to clean up, maybe it would have been much more neater. Who knows? Adediji Emmanuel, well done. All right. So anyway, this is nice. I can just imagine you having this set of questions in your exam. And this is how we do the preparation for acing any exam. I really trust that it's quite very possible for you to achieve great excellence in this exam. And that's why we're putting in the work to ensure that we can get the result, the desired result. So guys, don't relent. You're doing great. You're doing well. Stick to whatever you're doing. Tomorrow we'll be commencing with, we'll solve a question on mathematical induction tomorrow, because there's a question I wanted to solve this night, but we don't have time anymore. We'll solve that. Then we'll solve a question on at least sequence and series, and probably some other questions. So we want to exhaust O1 so that at the end of this year, by God's grace, you are able to crush any question on O1 before we then move on to whatever we have next. All right, guys, it's been, we have mapping, and we're going to do mapping and functions. So it's been a very great moment today. We were able to solve questions on mathematical induction. We solved question on partial fraction, and we solved question on trigonometry. All right, guys. I think at this point we have to start saying good night. You guys are doing great. You guys are wonderful. Don't forget, keep burning the midnight oil. You would see the success at the end of the journey. So don't relent at all. Don't relent at all. So practice until you cannot get it wrong. Practice until you cannot get it wrong. Solve questions, get questions, and if you have any problem, reach out to me. Enjoy yourself. Make sure you go to church tomorrow for those of you that are Christians. And sleep well and enjoy yourself. All right. I can see you guys. Good night. Good night. Enjoy yourself. Good night. Somebody is asking, hope I've eaten on a live feed. Okay, do you want to cook for me? Are you planning something for me? Okay, thank you too. Yeah, thank you for joining. Oh, somebody said he has a question. What's the question? Do we want to have your question quickly? Or do you want to reach out to me? Oh, you can cook for me. Somebody said let's continue. Somebody said I should go to church. Okay. Okay. You said you reach out. Okay, it's good. I think you should reach out. All right, guys. I'll be handing the live feed now. Take care of yourself. Bye-bye.